We've been talking about fossils. We've been talking about oil. We've been talking about how long it takes these rocks and fossils to form. Okay? Can anybody remember the age that I told you had been attributed to the rocks at the bottom of this formation? Not 20,000. 202 million years old. Anybody remember what the age has been attributed to the top of the formation?
182 million.
182 million years old. Okay, who's good at maths? How long did it take to lay down these rocks here, according to those dates? 202, what was that?
20 million.
20 million years. Excellent, yes. That is the secular dating. Okay? You then have to ask yourself, how deep is this formation? Because we can see the cliffs here, and the cliffs are what? 8, 9, 10 meters tall? Something like that here. They're not too big. But you know this isn't the only part of the formation. Because if you look out there, can you see the layers continue down? Right? Each one of those slabs is a layer of limestone that is on the slant that has gone down into the sea. So this formation goes down quite deep. Well, I actually know how deep this goes. You can find it on the British Geological Survey's website and things like that. It's around 30 meters deep. Okay? So, it took 20 million years to lay down 30 meters of sediment, correct? You're all following me, yeah? Okay, well, we can express 30 meters as 30,000 millimeters, yeah? It's exactly the same thing, all right? It just makes it easier for calculation. In other words, it took 20 million years to lay down 30,000 millimeters of sediment. Yeah? Good. How would we work out how much was being laid down each year then? It's a simple calculation. You simply take the 30,000, which is the height of your deposit, and you divide it by the time it was supposed to be laid down. So 30,000 divided by 20 million. Anybody good at maths? No? 0.0015. In other words, if the dates are accurate, only 0.0015 millimeters of sediment was being laid down here every single year. Okay, question. Can you put your fingers that close together?
No.
No. Okay. Question 2. Would you ever get a fossil if the rates were accurate?
No.
No, you would not. Because in order to get a fossil, you need to bury your creature really quickly. If you don't bury it quickly, then you won't ever get a fossil because that creature will become destroyed. And have we all found a fossil here today?
Yeah.
Yeah, there's tons of the stuff around. Even if you haven't been able to pick one up, you've certainly spotted so many of them. And they're big, aren't they? You remember the big ammonite we found back there? It was huge. This has been buried really quickly. It has certainly not been buried at 0.0015 millimeters per year. It's been buried at a much quicker rate than that. Now, where does this whole idea actually come from? Back in the 1660s, so quite a long time ago, a chap called Nicholas Steno developed a principle called the principle of superposition. This was a principle which taught that the bottom layer got there first, and then the next layer came on top, and then the next layer, and the next layer, and the next layer, right? And you've probably done the old, schoolroom, classroom sort of experiment where you get like a glass of water and you put sand in it, and you put stones in it, and you put mud in it, and you shake it up, and then you watch it all settle. Yeah?
And you drink it.
And then you drink, yeah. You can try and drink it. You know what I'm talking about, yeah? Well, that would be a wonderful analogy if the Earth was a glass of water, but it's not. The reality is there's only one way that you can actually move sediments into place in the real world, and that is by moving water. That is moving sideways. Think tides, think rivers, think deltas and estuaries, think currents. That water is moving sideways, from left to right or right to left, depending on which way you're standing on the bank, but it's moving sideways. It is carrying sediments and minerals in it, and it is dumping them down as it goes. Now, if you start to use that philosophy and start to replicate that kind of experiments in basically log flume, or big sort of flumes which you blast sediment and water, you realise that you get exactly the same kind of sediments that you get here. in exactly the same formations. These layers did not lay down slowly one on top of the others. These layers were laid down at the same time by water moving sideways, very, very quickly, carrying huge amounts of sediment and loads of creatures in that sediment and dumping it down extremely quickly all the way here. But it's not just here. Remember, we were talking about this earlier. It's not just here. It goes all around the UK, and then it goes all around the world. It's a huge, huge deposit, all being laid down at the same time, all being laid down around the world, which is starting to sound a lot like a worldwide flood, correct?
Validation is the process of confirming what is believed to be true by what can be observed to be true. Has this ever been done for radiometric dating, the process that gives us the very idea of long ages? Actually, long ages and radiometric dating hasn't stood up to the validation test. Radiometric dating has never been validated against the absolute known ages of rocks. Let us explain. Consider Mount St. Helens. This volcano erupted in the 1980s, giving scientists the opportunity to date the rocks that were formed from the eruption. The results? 5 different ages, all between 350,000 and 2.8 million years old, for rocks that we know were less than 30 years old. This discrepancy happens all the time in radiometric dating studies. In fact, there has never been a radiometric dating analysis that simply produces ages that validate to the known ages of rocks. And if radiometric dating doesn't work for rocks of known ages, why do we trust it for rocks of unknown ages? So the next time you hear millions of years ago this happened or that, just ask, how do you know that for sure? And if radiometric dating is the answer given, just ask, are you aware of a study where the radiometric age of a rock agreed with the known age of the rock? And you'll find the answer will undoubtedly be no. God wrote with his own hand that he created the heavens and the earth, the sea, and all that is in them in just 6 ordinary days. The genealogies in Genesis lead us straight back to Adam, just about 6,000 years ago. Have you ever noticed how hard the world pushes the idea of millions of years? Books, movies, museums, schools, it's everywhere. But does any of this even matter? Well, consider this. Many people will only consider the Bible's message if they believe the Bible to be credible, both historically and scientifically. Each person's eternity, either in heaven or hell, depends on what they believe about the risen Christ. And how do we know about this? Well, it's in the Bible. And if people don't believe the Bible got it right on the first page, who's going to trust the rest? So, because it takes faith to believe in either the Bible or the world's view of this distant past, is it a better choice to trust God or a fallible man? Download the Genesis Apologetics mobile app here for more videos on this topic and others.